What is the Laplace transform of t raised to the power of n? Let's look at our table of Laplace transform. It said it is n factorial over s to the n plus 1. So it is n factorial over s to the power of n plus 1. Alright, so we've seen this from the table. Let us look at an example of it. Now, I think that understanding and appreciation are improved if you see where something comes from, whether it's from a general or a specific example. Alright? Let's do that. Now, the Laplace transform of t to the n would be the integral from 0 to infinity of e to the negative st t to the n. Alright? But looking at that general form of the Laplace transform, or well, dt, I didn't write the dt. Looking at it from using that general form, it shows you the pattern but not very clearly. Right? So I'll use an example. A specific example, I mean. Suppose you find, say, the Laplace transform of t raised to the power of 3. It will be the integral from 0 to infinity of e to the minus st 2 to the 3 dt. Right? Now, let's quickly go through this. Let's use integration by parts, where u is equal to t to the 3 and dv is equal to e to the negative st. So du would be 3t squared and v would be e to the negative st over negative s. Now, let's call this L1, right? So, integral of u dv is equal to u v minus the integral of v du 3t squared dt, and the boundaries are from 0 to infinity. Now, here, if we put in the boundaries here, we'd be saying infinity raised to the 3 e 1 over e to the infinity over negative s minus 0 to the 3 1 over e to the 0 over negative s. That's what would happen. But we have our function in such a way that e to the negative infinity, we assume that it is smaller than e to the 3, because I think smaller than infinity to the 3, because infinity raised to the power of 3 would really be over e to the infinity. So here, well, if e to the infinity is smaller, I mean, infinity to the 3 is smaller than e. It rises slower than e to the infinity. It would approach 0. So this is 0. 0 times anything is 0. So what we have here is L1 is equal to negative times negative, so positive. Let's factor out. So it's 1 over s integral from 0 to infinity of e to the negative st times t squared. We factor out 3 as well. So we would have 3 over s e to the negative integral from 0 to infinity of e to the negative st t squared dt. Now, this is L1. Here we have 3 over s times, let's call this L2. L2, how do we do this now? Times L2, times L2, where L2 is equal to the integral from 0 to infinity of e to the negative st t squared dt. Let's work out L2, and remember it must be multiplied by 3 over s. Let's not forget that. Now here, L2, let's say u is equal to t squared, dv is equal to e to the negative st, so du is equal to 2t, and v is equal to e to the negative st over negative s. So in this case, integral of u dv is equal to u, which is t squared, times v, which is e to the negative st over negative s, minus the integral from 0 to infinity of v, which is e to the negative st over negative s, du, and du is 2t, and now have our dt there, right? So here, Laplace L2 that we're finding is, now remember the boundaries here, it goes from 0 to infinity, and the same thing that happened before, it happens again, so this amounts to 0, minus, then negative s, minus 1 over negative s, and we factor out 2 as well, so we factor out 2, integral from 0 to infinity of e to the negative st times t dt, right? Hope you're following. We're going a bit fast here. Hope you're following. Now, these two negatives, they cancel out. So what you really get is a positive 2 over st, 2 over s, integral from 0 to infinity of e to the negative st times t. Now, remember, this was L2. L2 must multiply by 3 over s. So let's do that. So we have 3 over s times 2 over s, integral from 0 to infinity of, let's put the t first, t, e to the negative st dt. I didn't have to put the t first, but to me it's kind of look a bit neater if I put the t first. I need to rebuild this t here, st. Alright, now let's call this L3, our third Laplace. L3 is like we're finding the Laplace transform of t here, and this one L2 was as if we're finding the Laplace transform of t squared, right? But anyway, this is the integral from 0 to infinity of t e to the negative st dt, and it must be multiplied by 3 by 2 over s by s, right? Now our u is t, our dv is e to the negative st, so the u is going to be 1 and v is going to be e to the negative st over negative s. Alright, now using integration by parts, what we have for L3 is integral of u dv is equal to u v minus the integral of v du, which is 1. So we have this going from 0 to infinity, and just as before, this will amount to 0 minus, now let's factor out negative s, put it behind the integral sign, so it's minus 1 over negative s is integral from 0 to infinity of e to the negative st dt. Alright? Now, this negative here, we're going to cancel this negative. So with what we have, this is our third L3 is this. L3 must be multiplied by 3 by 2 over s by s. So here, what we have is 3 times 2 over s times s, which is s squared, must multiply 1 over s integral from 0 to infinity of e to the negative st dt. Oh, let me write the dt down here. dt. But s times this is s cubed, so let's just do that. This is no longer s squared, it's s cubed. And put this as 3 by 2 by 1. Alright? Now, here, this here is not complete. Let's complete it over here, because we can't scroll down anymore. 3 by 2 by 1 over s cubed. Let's put it here. 3 times 2 times 1 over s cubed times, what was it? Integral from 0 to infinity of e to the minus st dt. Integral from 0 to infinity of e to the minus st dt. Now, let's integrate this part and see what we're going to have. What we have here, well, we wouldn't use an integration by parts because we only have one function here. So let's integrate it as it is. The integral of e to negative st dt is equal to, is going to be e to the negative st over negative s. Or we're going from 0 to infinity. We're going to multiply it by this later. We don't want to keep writing this thing over and over again, but let's remember that this is there. Alright, it's going from 0 to infinity. Now here, from 0 to infinity, again, remember, this is the same as e to the negative s times infinity. This is negative infinity over negative s minus e to the 0 times negative s times 0 is 0 over negative s. So what we have here, e to the negative infinity, is going to be the same as 1 over e to the positive infinity. I know that this is going to be 0. So it's 0 minus e to the 0 is 1 over s, right? So you see that? So it is negative 1 over s. Alright, so let's go back up here. This must multiply the negative 1 over s. So it's 3 by 2 by 1 over, so it's 3 times 2 times 1 times the 1 here, right? Over s cubed times, or alright, let's not put this one yet. 3 by 2 by 1 over s cubed. So this is what we have, 3 by 2 by 1 over s cubed. It must multiply this 1 over s cubed, right? It must multiply this. So, oh my, hold on. Made a little mistake here. This is negative s, is e to the this. This negative and this negative. Okay, this was a negative and I didn't put it back here. I just realized that. I need to put back the negative here. Oh, so this negative and this negative, which will make this positive. So it's a positive 1 over s then. So it's 1 over s. Now this will be 3 times 2 times 1 times 1. well, we would need to repeat this times 1. When you multiply by 1, you get back the same thing. This over s to the 3 times s. But s to the 3 times s is s to the 4. So what this gives you is 3 factorial over s to the 4. Now 3 factorial over s to the 4 is the same as 3 factorial over s to the 3 plus 1. So 3 factorial, the Laplace transform of t to the 3 is 3 factorial over s to the 3 plus 1. Now, it kind of looks like t to the Laplace transform of t to the n is n factorial over n, s to the n plus 1. Laplace transform of t to the 3 is 3 factorial over s to the 3 plus 1. Right, so that's one specific example showing that the Laplace transform of t to the n is n factorial over s to the n plus 1. Now remember, in exam, you'll be given a table of Laplace transform. But remember also, you might see a question asking you to prove that t to the n is n factorial over s to the n plus 1, or to give an example to show it. Alright? So these are various Laplace transforms. Alright? You might be asked to show that the Laplace transform of 1, the Laplace transform of t is 1 over s squared, or the Laplace transform of 1 is 1 over s, or that the Laplace transform of e to the minus at is 1 over s plus a, that the Laplace transform of at is a over s squared plus a squared, or the Laplace transform of I said at, of sine at I should have said, is equal to a over s squared plus a squared, or that the Laplace transform of cos at is s over s squared plus a squared. Alright? You might be asked to show that, but for the most part, you would be given a table of Laplace transform that you would use in exam.